Hello and welcome. I will be answering Jamb 2011 Physics Past Question 2. A carpenter on top of a roof 20 meters high dropped a hammer of mass 1.5 kilograms and it fell freely to the ground. The kinetic energy of the hammer just before hitting the ground is A. 300 joules, B. 450 joules, C. 600 joules, D. 150 joules. And we are given G, acceleration due to gravity, as 10 meters per second square. Now what we are looking for here is the kinetic energy of the hammer, but not just the kinetic energy of the hammer, specifically the kinetic energy of the hammer just before hitting the ground. Now, one of the principles of conservation of mechanical energy, as observed when an object is falling from a height freely under the influence of gravity, is that just before that particular object hits the ground, the kinetic energy will be equal to the potential energy. So the formula you use to get the kinetic energy will be the same formula you use to calculate the potential energy, which in this case is mgh. So that is the formula you will be making use of. Now you just substitute the values given to you directly. M, which of course is your mass, 1.5 kg, multiplied by G, acceleration due to gravity, which is 10, and then multiplied by the height, which is 20, and that altogether will give you 300 joules. Joules of course being the unit of energy, in this case potential or kinetic energy. So 300 joules is option A, which is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 3. Two balls X and Y weighing 5 grams and 50 kilograms respectively were thrown up vertically at the same time with a velocity of 100 meters per second. How will their positions be 1 second later? A. X will be 500 meters ahead of Y. B. X and Y will both be 500 meters from the point of throw. C. X and Y will be 500 meters from each other. D. Y will be 500 meters ahead of X. So we have a scenario here with two objects of different mass. Of one is 5 grams, the other is 50 kilograms, and they are thrown up vertically with the same velocity at the same time. So I asked for their positions, or the distance they would have traveled 1 second later. Now of course this is under motion, and one of Newton's equations of motion is v squared is equal to u squared minus 2gs. So we can use this to get the position or distance traveled after the stipulated time. Now v, which is our final velocity, will be taken as 0. U, which is the initial velocity, is the 100 meters per second, minus 2 multiplied by G, which is acceleration due to gravity, approximately 10 meters per second square, multiplied by S. So S is the distance after that particular time, and it is of course unknown, and is what we are looking for. So all these 0 will be equal to, if you multiply everything here, okay, sorry, this is 100 square, u square, okay, so this is also 0 is equal to 10,000 minus 20s. Taking 20s to the other side, 20s equal to 10,000, so divide through by 20. So S is equal to 500 meters. Now 500 meters will be the distance covered by any of the objects. Now looking at this calculation we just made here, one thing you can deduce is that it is independent of mass. So irrespective of the mass of the object, this same reaction will hold, these same parameters will be used, and this is the same result you will get. So irrespective of whether the object is 5 grams or 50 kilograms, if you throw them up, if you throw the object up vertically with this velocity, this is the distance it will cover in 1 second. So since it is independent of mass, it is safe to say that both objects will have covered the same distance from where the position they were thrown from. So that is what is seen here in option B. X and Y will both be 500 meters from the point of throw. So this is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 4. A man standing on a lift that is descending does not feel any weight because A. There is no reaction from the floor of the lift. B. There is no gravitational pull on the man in the lift. C. The inside of the lift is airtight. D. The lift is in vacuum. So we are basically asked for the reason why a man standing on a lift that is descending experiences weightlessness, experiences that feeling of weightlessness. Now, resultant force, which we represent as W, is usually given as mg, which is the weight of the object minus the normal reaction. Now, but in this case, the normal reaction is equivalent to the weight of the man, which is mg, that is the mass of the man multiplied by acceleration due to gravity. So therefore, the resultant force will be equal to mg minus mg, and therefore is equal to 0. So there is no normal reaction. There is no reaction from, in this case, the floor of the lift. There is no normal reaction or reaction from the floor of the lift, and for this reason the person within the lift will experience weightlessness. And option A says there is no reaction from the floor of the lift, so option A is the answer to our question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 5. So you have this diagram here, and the diagram above shows two vectors at right angles to each other. The value of the resultant vector is A. 12.0 Newton, B. 13.0 Newton, C. 14.0 Newton, D. 10.0 Newton. So this is actually a very straightforward question under vectors, and we have to find the resultant vector. So the formula for that is actually straightforward. The resultant vector is equal to the square root of p square plus q square, where p and q represent each of these sides. Okay, so let's call here our p and let's call here our q. So this is what you use to resolve that. So r is equal to square root 6 square plus 8 square, which is equal to the square root of 36 plus 64, and that is equal to the square root of 100, which is equal to 10 Newton. So 10 Newton, 10.0 Newton is option D. So D is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 6. An object of mass 2 kg moves with a velocity of 10 meters per second round a circle of radius 4 meters. Calculate the centripetal force on the object. A. 50 Newton, B. 40 Newton, C. 25 Newton, D. 100 Newton. So we are asked to calculate the centripetal force of an object. Now the formula for centripetal force, F, is equal to mv square over r. So m, of course, which is the mass of the object, is given 2 multiplied by v, which is velocity, 10 square, over r, which is the radius of the circular path. So that is 4 meters, and this is equal to 10 square is 100, so 100 multiplied by 2 is equal to 200, over 4. So 200 over 4 is equal to 50 Newton. 50 Newton is option A. So option A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 7. If it takes an object 3 seconds to fall freely to the ground from a certain height, what is the distance covered by the object? A. 45 meters, B. 60 meters, C. 90 meters, D. 30 meters. And we're giving our value of G, acceleration due to gravity, is equal to 10 meters per second square. Now we're asked to calculate the distance of free fall. This can also be referred to as the distance of free fall. Okay, and the formula for the distance of free fall S, is equal to half gt square, where g of course is our acceleration due to gravity, and then t is the time taken for the object to complete its free fall. So S is equal to 1 over 2 times 10 multiplied by 3 square, and that is equal to 5 multiplied by 9, which is equal to 45 meters. 45 meters is option A, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 8. So you have 3 diagrams labeled X, Y, and Z. So the diagrams above show the positions of a cone. The position, which can be described as neutral equilibrium, is represented as A. Y and Z, B. Y and X, C. Z only, D. X only. Now we're asked to point out the object or objects that is in neutral equilibrium. Now first, let's define what neutral equilibrium is. Now neutral equilibrium is when a body is in a position in which, when it is slightly displaced, it tends to come to rest in its new position. So good examples of objects that can be described as being under neutral equilibrium include a cone resting on its side, a ball on a flat table, etc. So any object that is in a position such that when you displace it, it comes to rest in a new position, that object is said to be in neutral equilibrium. Now let's take a look at this object. Now from this object, we described a cone resting on its side. Now if you look at option the diagram Z, what is illustrated here is a cone resting on its side, which is a perfect example of an object under neutral equilibrium. So Z is part of the object, okay, it's under neutral equilibrium. Now as for Y, the way the cone is, if you displace it, what will happen is that it will return back to its original position, so it is not in neutral equilibrium. And for X, when you displace it, it is further, or it's likely to move further away from this initial position and come to rest in a completely different position, so it is not under neutral equilibrium. So as we have rightly established, Z, which is option C, Z only, is under neutral equilibrium. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 9. If a tube of small radius opened at both ends is placed in a liquid, the liquid will A. Fall below the liquid level if the liquid does not wet the glass. B. Rise above the liquid level if the liquid does not wet the glass. C. Remain at the same level irrespective of whether the liquid wets the glass or not. D. Fall below the liquid level if the liquid wets the glass. So when you open a tube at both ends, what you are trying to study or what you are trying to form is a capillary tube, and you are trying to study capillary action or capillarity. Okay, now the rule of this is that the liquid will rise up the capillary tube if it wets glass, and it will fall below its initial level if it does not wet glass. So this is the ground rule for capillary action. Now the last part of what we just stated says fall below its initial level if it does not wet glass, and that is what is seen here in option A. Fall below the liquid level if the liquid does not wet the glass. So option A is what is observed. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 10. So you have 3 items listed here: density of the liquid, depth below the surface of the liquid, and surface area of the liquid. Now, in which of the following statements above will pressure be dependent? A. 1, 2 and 3, B. 1 and 3 only, C. 1 and 2 only, D. 2 and 3 only. So basically we are asked for factors that the pressure of a fluid or liquid depends on. Okay, now based on standard, the pressure of liquid is usually dependent on the density of the liquid. So the more dense a liquid, the more, so higher density means higher pressure. The higher the density, the more the pressure it will exert on the pressure the fluid or the liquid will exert. And then the second one says depth below the surface of the liquid. Now this is also depth below the surface of liquid. As deeper, the more the depth, the higher the depth, or the lower the depth in this case, the more pressure it also exerts. Now the only item here that does not affect pressure of a fluid is the surface area of the liquid. The surface area of the liquid is not a factor that influences density. So we're asked for which one pressure will be dependent on. So we have picked out 1 and 2, okay, as factors which pressure is dependent on. So 1 and 2 only is option C, the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 11. You have 4 items listed here, or 4 properties: high thermal capacity, high sensitivity, easy readability, accuracy over a wide range of temperatures. Now the question is, from the statements above, the qualities of a good thermometer are A. 1, 3 and 4, B. 2, 3 and 4, C. 1 and 2, D. 1, 2, 3 and 4. So you have these 4 properties here, and which of them can be described as qualities of a good thermometer? Now, when talking about high thermal capacity, they are talking about the ability for it to retain or absorb heat And any material that's able to absorb or retain heat is also capable of transferring heat. Now, high sensitivity, of course, talks about how quickly it responds to changes in temperature. 3 says easy readability, and easy readability just means the property of it or ability to detect changes in temperature. And 4 says accuracy over a wide range of temperature. That is also ability to take readings or to detect changes over a wide range of temperature. Now, we're asked for which is not a quality or which is a quality of a good thermometer. Now, high thermal capacity is not a quality of a good thermometer, because a good thermometer should not be able to absorb or retain heat or transfer heat, because it could affect the temperature of the body, okay, from which you are measuring, the body which you are taking the temperature reading from. So it is not a quality. But for high sensitivity, a good thermometer should be able to respond to changes in temperature. It should be easy to read. You should be able to detect, the changes in temperature, and you should also be able to accurately record temperature over a wide range. So that is 2, 3, and 4. 2, 3, and 4 is option B. So option B is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 12. A machine is used to lift a load of 20 Newton through a height of 10 meters. If the efficiency of the machine is 40%, how much work is done? A. 300 joules, B. 120 joules, C. 80 joules, D. 500 joules. So this is a question under efficiency, or it is related to efficiency of a machine. And mathematically, efficiency is given as the work output divided by the work input times 100 over 1. So from the equation, we are given the efficiency as 40%, so that is 40 equal to the work output is given to us, which is 20 lifted through a height of 10, so that is 20 multiplied by 10 divided by the work input is what we are looking for, how much work is done. So that is, let's call it x, and then times 100 over 1. So this all multiplied by, this and then this cross multiplied, that is 40x is equal to 20 multiplied by 10 multiplied by 100. So you divide through by 40, and then x, 40, then x will be equal to 500 joules. 500 joules is option D, as we see here. So it is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 13. Which of the following could be effectively used to reduce friction? A. Water, B. Petrol, C. Kerosene, D. Grease. D. Grease. So we're asked for which of these 4 substances could be effectively used to reduce friction. Now, water actually has some lubricating properties. However, it is not the lubricating property, or the property to reduce friction is not sufficient for effective friction reduction. It's not sufficient for effective friction reduction. Now, petrol is not known for its ability to reduce friction. It is known for its use as fuel, either as combustion fuel combustion fuel, or even propulsion fuel. So it is not known for its friction reducing property. Kerosene is also best used as a combustion fuel. It is not known for its ability to reduce friction. However, option D, which is grease, is known for its lubricating property. Okay, and lubrication is basically a way or a very effective method in reducing friction. Now, grease is made up of mixing oil and other thick materials. Okay, it is made with mixing oil and other thick materials, and like we said, it's an effective lubricating material compared to the other three. So option D, which is grease, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 14. A copper wire was subjected to a tensile stress of 7.77 times 10 raised to power 7 Newton per meter square. Calculate the tensile strain of the wire. A. 7.0 times 10 raised to power minus 4. B. 2.2 times 10 raised to power minus 4. C. 2.0 times 10 raised to power minus 5. D. 7.0 times 10 raised to power minus 3. And we are given the value of Young modulus as 1.1 times 10 raised to power 11 Newton per meter square. Now, Young modulus, which of course is given to us, is mathematically given as tensile stress over tensile strain. Now we have the value of Young modulus given to us, and we have the value of tensile stress given to us. So all we need to do is to make tensile strain subject of the formula to calculate its value. So tensile strain, if you make it subject to the formula, is equal to the tensile stress divided by the Young modulus, and then substituting the values, tensile stress 7.77 times 10 raised to power 7 divided by Young modulus 1.1 times 10 raised to power 11. So both units are Newton per meter square, so that is why they will cancel out, and that's why here you do not have any unit. So tensile strain does not have a unit. So if you divide this, the answer you get is 7.0 times 10 raised to power minus 4. So 7.0 times 10 raised to power minus 4 is option A, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. And welcome. I will be answering Jamb 2011 Physics Past Question 15. An object weighs 22 kg in water and 30 kg in air. What is the upthrust exerted by the liquid on the object? A. 220 Newton. B. 80 Newton. C. 50 Newton. D. 520 Newton. And you have the value of G, acceleration due to gravity, as 10 meters per second square. Now, in order to solve this, you make use of the formula for upthrust. And upthrust is usually given to us as weight in air minus weight in liquid. Now, weight in air, of course, is the mass multiplied by acceleration due to gravity, mass in air multiplied by acceleration due to gravity, minus weight in liquid, which is the mass in liquid multiplied by acceleration due to gravity. Now, the mass in air is given to us as 30 kilograms, and the mass in the liquid, which is water in this case, is given to us as 22 kilograms. So acceleration due to gravity is given to us as 10. So for the weight in air, that is 30 multiplied by 10 minus 22 multiplied by 10. Okay, and solving that will give you 300 minus 220, and that is equal to 80 Newton. So 80 Newton is the upthrust exerted by the liquid on the object. 80 Newton is option B, which is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 16. A block of aluminium is heated electrically by a 30-watt heater. If the temperature rises by 10 degrees Celsius in 5 minutes, the heat capacity of the aluminium is A. 100 joules per Kelvin, B. 200 joules per Kelvin, C. 900 joules per Kelvin, D. 90 joules per Kelvin. So in this sort of question, what you need to remember is heat supplied is equal to the heat gained. Heat supplied is equal to heat gain. Now, heat supplied in this case is what is the heat supplied by the electrical source, which is in this case the 30-watt heater. So the heat supplied will be equal to P times T, which is the power of the heater multiplied by the time it was heated for, and this is equal to MC theta. Heat gain is equal to MC theta. So M is the mass of whatever is given to you, C is the specific heat capacity, and theta is the heat change or the heat gain. Okay, now what you have to get is the heat capacity, and that you can re-express this as P times T is equal to C theta, where C is equal to MC. Okay, so C of course is the heat capacity, while MC together is the specific heat capacity. Now PT, that is 30 watts, 30 times time 5. Now you have to convert this to seconds, so you multiply it by 60, so equal to C, the heat capacity which you are looking for, multiplied by the heat gain, which is 10 degrees Celsius, so multiply by 10. So C is equal to 30 times 5 times 60 divided by 10, and this is equal to 900 joules per Kelvin. 900 joules per Kelvin is option C, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. And welcome. I will be answering Jamb 2011 Physics Past Question 17. A perfect emitter or absorber of radiant energy is A. White body, B. Red body, C. Conductor, D. Black body. Now, you have 4 options, of course, given to you, and you are asked, how do you describe, or what is the best way to describe an object which is a perfect emitter and absorber of radiant energy? Okay, radiant energy. Now, usually it's actually a very straightforward question, and this description is usually associated with a black body. Now, a black body or a black surface, okay, is usually known to be a good emitter or absorber of radiant or heat energy even. Okay, so a conductor is more or less just a conductor is basically just a material that is good at absorbing any form of energy, either electrical energy or heat energy. But for radiant energy, perfect absorption and perfect emission of radiant energy is usually associated with a black body or a black surface. So option D says black body, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 18. The phenomenon that shows that increase in pressure lowers the melting point can be observed in A. Coagulation, B. Regulation, C. Sublimation, D. Condensation. Now you have 4 phenomena here, and you are asked for the one which indicates this, okay, which indicates that increase in pressure lowers melting points of a particular substance. Now, coagulation just refers to the clumping of any substance, clumping or coming together or aggregation of any substance. So it doesn't exactly indicate anything about pressure and melting point. So this is not the answer to the question. Now option B says regulation. Now regulation is the phenomenon of, or that shows melting under pressure and freezing when pressure is reduced. So in regulation, basically what is indicated is melting under pressure. So when the pressure is increased, the melting point decreases, and thus melting occurs. Okay, melting occurs much more quicker when more pressure is applied. So you can say increase in pressure indicates decrease in melting point. That is regulation. Now option C says sublimation, and sublimation refers to when solids are converted or transformed to gas without changing to liquid. Solids converted or changed to gas without being converted to liquid first. That is sublimation. And option D says condensation. Okay, condensation. And condensation refers to when gases are converted to liquid. That is condensation. Now from what we've explained from the four options, option B, which is regulation, is the one that indicates this increase in pressure lowering the melting point of a substance. So option B, okay, option B, regulation, is the correct answer to this question. Regulation is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 19. If the volume of a gas increases steadily as the temperature decreases at constant pressure, the gas obeys A. Pressure law, B. Charles law, C. Graham's law, D. Boyle's law. So you have four gas laws given to us, and we're asked for the one which describes the volume of a gas increasing as temperature decreases at constant temperature. So this is more or less like an inverse proportionality. So which of the following describes inverse proportionality between volume and temperature? Okay, now, and of course at constant pressure. Now option A says pressure law. Now pressure law states that for a fixed mass of gas at constant volume, okay, pressure is directly proportional to absolute temperature. So as you can see, this does not describe what we have here, and it is not the answer to the question. Now option B says Charles law. Now Charles law actually has to do with the volume and temperature of gas, and Charles law, which has to do with volume and temperature of the gas, states that the volume of a gas equals a constant value multiplied by its temperature as measured on Kelvin scale. Okay, so this shows that, or this basically indicates that there is a direct relationship between volume and temperature. Okay, volume and temperature if the pressure is constant. So option C talks about Graham's law, or Graham's law of diffusion, and Graham's law of diffusion states that rate of diffusion of a gas R, okay, rate of diffusion of a gas, which is given as R, is inversely proportional to the square root of the molecular weight of that gas. So it is not the answer to the question. And lastly, Boyle's law states, okay, which has to do with pressure and volume, states that pressure is inversely proportional to volume. The pressure of a gas is inversely proportional to its volume, provided that temperature remains constant. Okay, so from what we've seen here, the one that has to do with volume and temperature is Charles' law, and Charles' law is option B, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 20. Steam burn is more severe than that of boiling water because A. Water boils at a higher temperature. B. Steam burn is dependent on relative humidity. C. Steam burn is independent of relative humidity. D. Steam possesses greater heat energy per unit mass. So I asked for the reason why a steam burn is more severe than a boiling water burn. Now the answer to this is actually simple. It is actually because steam has higher heat energy per unit mass than water. Okay, now as proof of this, specific latent heat of vaporization of steam is equal to 2.1 times 10 raised to the power 6 joules per kg. Okay, so this is the heat energy per unit mass. However, for water, okay, the amount of heat required to heat 1 kg or a unit mass of water, okay, heat required to raise the temperature of 1 kg of water is given as 4.2 times 10 raised to the power 5 joules per kg. So you can see that this is actually higher, okay, times 10 raised to the power 6 than this. So this is the explanation behind that. So D, steam possesses greater heat energy per unit mass. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 21. Which of the following types of sound of waves needs a medium for propagation? Which of the following types of waves needs a medium for propagation? A. Radio waves. B. X-rays. C. Sound waves. D. Light waves. So we are given 4 options here, and of course we are asked to pick out the type of wave which requires a medium for its propagation. Now, to answer this question, it will be important to first note that radio waves, X-rays, and light waves or visible light are classified as electromagnetic waves, and these waves do not require a medium for propagation. That means they can be propagated through vacuum. However, sound wave is a longitudinal wave. Sound wave is a longitudinal wave, and longitudinal waves, of course, require a material medium or a medium for propagation. Mediums such as air or water or wood, etc. So it requires a medium for its propagation. So option C, which is sound wave, is a wave that needs a medium for propagation. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 22. The ground is always cold at night because the A. Sun no longer shines at night. B. Atmosphere reflects the sun's energy at night. C. Atmosphere absorbs the sun's energy at night. D. Earth radiates heat to the atmosphere at night. So I asked for the reason why the ground or the floor is always cold at night or during night time. Now, the simple reason behind this phenomenon is that the Earth radiates heat to the atmosphere at night, thereby lowering the temperature or reducing the temperature of the ground. So of course during the daytime the ground would be heated by the sun's energy or the heat from the sun. However, at night, due to the process of radiation, that is transfer of heat without a medium, an intermediate medium, the earth would radiate that heat to the atmosphere during the night. So as it radiates the heat to the atmosphere, the ground or the temperature of the ground decreases, and hence the reason why the ground is cold at night. So that explanation is captured in option D. The earth radiates heat to the atmosphere at night. So D is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 23. A metal of volume 40 centimeter cube is heated from 30 degrees Celsius to 90 degrees Celsius. The increase in volume is A. 1.20 centimeter cube, B. 0.40 centimeter cube, C. 0.14 centimeter cube, D. 4.00 centimeter cube. And we're given the linear expansivity of that particular metal as 2.0 times 10 to the power minus 5 per Kelvin. Now, we are obviously looking at increase in volume with increase in temperature, and that is seen in cubic or volume expansivity. Okay, now there is a formula for cubic expansivity. Okay, cubic expansivity or volume expansivity is given by the symbol gamma. Okay, and it's usually given as the increase in temperature, that's the increase in volume, over initial volume multiplied by the change in temperature. Okay, now we are faced with something here. We are given the linear expansivity, okay, not the cubic expansivity, and we're asked to calculate the increase or change in volume. Now, it's important to note that the cubic expansivity is equal to 3 times the alpha, or 3 times the linear expansivity. Okay, that is 3 alpha. Okay, so if you make increase in volume, that is V2 minus V1. If you make this the subject of the formula, V2 minus V1 equal to 3 alpha V1 theta. Okay, so this remember we said gamma is equal to 3 alpha, or 3 multiplied by alpha, so that is equal to 3 times alpha is of course our linear expansivity, 2.0 times 10 raised to the power minus 5 times 40, okay, times the change in temperature. So change in temperature is 90 minus 30, so that is equal to 3 times 2.0 times 10 raised to the power minus 5 times 40 minus multiplied by 60 rather. So this is equal to, if you multiply all these together, that is equal to 0.144 centimeter cube. 0.144 is approximately 0.14 centimeter cube, and that is C, 0.14 centimeter cube. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 24. So you have 4 items here: change of state, diffusion, radiation, and osmosis. And I asked which of the processes above can be explained using the kinetic theory. A. 1, 3, and 4. B. 1, 2, and 4. C. 1, 2, 3, and 4. D. 1, 2, and 3. Now, the kinetic theory is basically a scientific theory that describes the particulate nature of matter in relation to the movement of those particles with change in certain factors, with the most notable of those factors being temperature. So that is what the kinetic theory is all about. So which of the following processes given to us can be explained using this kinetic theory or kinetic idea? Now, one says change of state. Now, change of state can actually be explained using the kinetic theory, as the change of state according to kinetic theory has to do with change in temperature, which alters the movement of the particles by altering the intermolecular forces of attraction between these particles. So the more mobile, or when you have solid particles, of course the movement of the particles is not that much, it's not free, because of the high intermolecular force of attraction between the molecules or the particles of that particular substance. But when you increase the temperature, it changes to liquid because the intermolecular force of attraction is reduced, and hence the movement of the particles is increased. And that also applies to when you further increase the temperature and then it changes to gas. So change of states can actually be explained using the kinetic theory. Now, option or item 2 says diffusion. Now, diffusion refers to movement of particles from a region of high concentration to region of low concentration. So this has to do also with particles, and it's also affected by the factors which you mentioned under kinetic theory. So it can be explained using kinetic theory. So diffusion is part of it. Now, 3 says radiation. Now, radiation has to do with heat transfer without medium. That is actually how the heat from the sun gets to the earth, via radiation. So it has to do with heat transfer without a medium, and intermediate medium. Now, radiation actually can't be explained using the kinetic theory, because like we said, you are not exactly describing any medium, you're only describing transfer of heat. So you cannot use the kinetic theory to explain radiation. So radiation is out. And then 4 says osmosis. And osmosis refers to movement of solvent particles from a region of low concentration to a region of high concentration through a semi-permeable membrane. Now, similar to diffusion, it actually has to do with particles, and the factors that we described under kinetic theory, such as temperature, actually affects the rate of movement of these particles. So osmosis can be explained using the kinetic theory. So we have listed 1, 2, and 4 as the phenomena which can be explained using the kinetic theory, and 1, 2, and 4 is option B. So B is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 25. when the human eye loses its power of accommodation, the defect is known as A. Astigmatism, B. Long-sightedness, C. Short-sightedness, D. Presbyopia. So you have 4 eye defects given to us here, and we are asked which of them is described as a situation where the human eye loses its power of accommodation. Accommodation simply just refers to the process or the ability of the human eye to adjust as appropriate in order to view whatsoever image or whatsoever image is placed before it, irrespective of the distance. Okay, so that is accommodation. Now, astigmatism is an eye defect which actually refers to imperfect curvature of the cornea. Now, because the cornea is not perfectly curved, the light rays is not able to actually be converged as required within the eye or focused as required on the retina. So this imperfect curvature of the cornea is known as astigmatism, and as you can see here, it's not actually what is described in the question, so it is not the answer to this question. Now, option B says long-sightedness. Now, long-sightedness refers to the ability of the human eye to only view distant objects. Now, this is usually due to the fact that the eyeball is too small, so images are usually formed behind the retina. Okay, so the individual has to take the image far away so it can be seen properly. Now, this actually again does not describe what we have in the question, so it is not the answer to the question. Now, C says short-sightedness, which is the opposite of long-sightedness and refers to the ability to only view near objects, and it is the opposite, like we said, because the eyeball is too long or too large and images are formed in front of the retina, so the individual has to bring the object close to his eye in order to be able to view the object well. So this is also not what is described in the question, so it is not the answer to this question. But D says presbyopia. Now, presbyopia is best or usually described as loss of accommodation due to inability of the lens to focus on objects. Now, it is usually associated with advancing age, so it's an eye defect usually associated with the elderly. So it is actually what we have described here in the question. So D is the answer to this question, presbyopia. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 26. A length of wire has a frequency of 255 Hz when stretched by a force of 225 Newton. If the force increases to 324 Newton, what is the new frequency of vibration? A. 488 Hz, B. 356 Hz, C. 306 Hz, D. 512 Hz. So we have a frequency of a wire given to us here when it is stretched by this force, and we're asked what the new frequency of vibration will be if the force is increased to this. So F1, which is the initial frequency, okay, at this particular force, is 255 Hz, and then F2 is what we are looking for, the new frequency. Now we'll describe the forces as T. So T1 is 225 Newton, and then T2 is 324 Newton. Now, frequency of vibration is directly proportional to the square root of the force, the applied force. Therefore, when you have two frequencies and two forces given to you, this is the formula you would make use of. F1 over root T1 is equal to F2 over root T2. So you substitute the values into this formula given to you directly. So F1 255 divided by T1, which is 225. Remember, square root of it is equal to F2, which is unknown to you, and T2, root T2, which is 3 root 324. Now F2 will therefore be equal to 255 times root 324 divided by root 225, and this is equal to 255 multiplied by 18 over 15, which is equal to 306 hertz. So 306 hertz is the new frequency of the vibration, F2, and that is option C, which is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 28. Which of the following electromagnetic waves has the highest frequency? A. Infrared rays, B. X-rays, C. Ultraviolet rays, D. Radio waves. So usually when discussing electromagnetic waves, there is a manner in which they are arranged in increasing order of frequency, or in order of increasing frequency. Okay, so the mnemonic revox G is usually used. So the first is radio waves with the lowest frequency, followed by infrared rays, followed by visible light, followed by ultraviolet or UV rays, followed by X-rays, and then finally gamma rays. So in order of increasing frequency. So we asked for the one which has the highest frequency here. Now radio waves has the lowest frequency among all the EM waves, so it is the first here, so D is not the answer. Infrared rays is the second lowest. Okay, second lowest, so it is not the answer. Now UV rays, you have it here, but UV ray, of course, from this sequence we have, has lower frequency than X-rays, so ultraviolet rays is not the answer. So the one with the highest frequency here is B, X-rays. So X-rays is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 30. The eclipse of the sun occurs when A. Moon is not completely hidden in the Earth's shadow, B. Moon's umbra falls on some parts of the Earth, C. Moon is between the sun and the Earth, D. Earth is between the sun and the moon. Now the eclipse of the sun is also referred to as the solar eclipse, and basically we are asked to explain the actual phenomenon behind the solar eclipse. Now in the solar eclipse, what happens is that the moon is between the sun and the earth. Now when this happens, the moon casts a shadow over the earth. So it's usually associated with sudden darkness, probably like in the day, during the afternoon you just see there will be a sudden darkness. Now this is because the moon is between the sun and the earth, and then obstructing the rays of the sun from reaching the earth, and then casting a shadow over the earth. So that is the eclipse of the sun, or solar eclipse, and that is what is seen here in option C. The moon is between the sun and the earth, so C is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 31. A cannon is fired from town X After how long is the sound heard at town Y? 4.95 kilometers away. A. 12 seconds. B. 15 seconds. C. 30 seconds. D. 10 seconds. And we're giving velocity of sound in air as 330 meters per second. Now, the formula for velocity, okay, when you have velocity of sound in air, the formula for that is given as 2x over t, where x is equal to the distance, where x is equal to the distance. Now, in this case, we are given the velocity of sound in air, that is our v. We are given our x, which is this distance of town Y from town X, that is 4.95 kilometers. Now we're asked for the time, we're asked to calculate the time. So in order to do that, we substitute the values. So 2 multiplied by x. Now this x is in kilometers, so we need to convert it to meters. So multiplied by 1000 and then divided by t. So t is equal to, this multiplied by this is 9.9 times 1000 over 330. So we made t subject of the formula here. Now divide all this and you get 30. So that is 30 seconds. And 30 seconds is option C. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Physics past question 32. An image in a convex lens is upright and magnified 3 times. If the focal length of the lens is 15 centimeters, what is the object distance? So we're asked to calculate object distance given the magnification of that particular image and the focal length of that particular lens. So it will be important to note that magnification is equal to V over U. Magnification is the ratio of the image distance to the object distance, and the magnification is given to us as 3, so magnified 3 times. Now it's important to know that it is a convex lens, so that means it is virtual and hence it is negative. So it is, the magnification is -3, and so let's substitute that here. -3 is equal to V over U. This means that V is equal to -3U. Now the formula 1 over F is equal to 1 over V plus 1 over U. So our V is -3U. So, and we are given our focal length, that is F. So 1 over 15 is equal to 1 over -3U plus 1 over U. Now 1 over 15 is equal to 2 over 3U. This is equal to 2 over 3U. Okay, so if we invert that, 15 is equal to 3U over 2. So this way, 15 multiplied by 2 is equal to 3U. That is 30 equal to 3U. Divide through by 3. U is equal to 10 centimeters. And 10 centimeters is option C, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 33. The capacitance of a parallel plate capacitor is 20 microfarads in air and 60 microfarads in the presence of a dielectric. What is the dielectric constant? A. 3.0, B. 2.0, C. 0.3, D. 6.0. So this is actually a very straightforward question. The dielectric constant is equal to C over C naught, where C is the capacitance, C is capacitance in presence of a dielectric, and C0 is the capacitance in air. So there is no need to convert it because it is ratio, and the dielectric constant of course has no unit. So even if you convert it to farads, you are still actually going to get the same answer. So this is equal to 60 over 20, which is equal to 3.0, and that is option A. So 3.0A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 34. So you have this diagram, a diagram of a circuit, and it says in the circuit above, 3 resistors, 2 ohms, 4 ohms and 12 ohms are connected in parallel, and a 12-volt battery is connected across the combination. The current flowing through the 12 ohm resistor is A 3.2 amps, B 9.6 amp, C 14.4 amp, D 1.0 amp. So this is actually a parallel circuit, and in a parallel circuit the current flowing through each resistor is actually different. So I asked to calculate the one that is the current amount of current flowing through the 12 ohm resistor alone. Now Ohm's law, that is V equal to IR, so we are looking for current, so I is equal to V over R. So we will calculate the current using the resistor, the 12 ohm resistor given to us, and the voltage, the 12 volt voltage. So I will therefore be equal to 12 over 12, which is equal to 1.0 amperes. 1.0 amperes is option D. So that is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 35. If the charge of electricity per kilowatt hour is 4 naira, what is the cost of operating an electrical appliance rated 250 volts, 2 amps for 6 hours? A 16 naira, B 24 naira, C 28 naira, D 12 naira. So for this calculation of cost per kilowatt hour, energy consumed is equal to power multiplied by time, and power is equal to IV, so time is equal to T, so IV T. So our I, which is our current, is 2 amps, so that is 2 multiplied by V, which is the voltage, so 250 multiplied by T, that is time in hours. Remember, we are working with kilowatt hour, so time will remain in hours. So this, all this is equal to 3000 kilowatt hours. Now 3000 kilowatt hours divided by 1000 is equal to this is in watt hours, because our power is in watts, the power we get is in watts, so this is watt hours. Now watt hours, so divided by 1000, that is 3 kilowatt hour. Now 1 kilowatt hour costs 4 naira, therefore 3 kilowatt hours will cost 4 times 3, which is equal to 12 naira. 12 naira is option D, which is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 36. The correct expression for the potential at a point, distance r from a charge q in an electric field is A q over 4 pi epsilon naught r square, B q over 4 pi epsilon naught r, C q square over 4 pi epsilon naught r square, D q square over 4 pi epsilon naught r. Now electric potential electric potential is the work done in taking a unit mass of charge from infinity to a point, to a particular point. Now that's actually giving us W over Q, that is the work done. Okay, W over Q, so FR over Q. Okay, so that's actually equal to Q1 Q2 over 4 pi epsilon naught R squared. This 4 pi epsilon naught is a constant multiplied by R over Q1. So all in that, for a charge Q, that will be equal to Q over 4 pi epsilon naught R, as this will cancel out this and R will cancel out one of these R's. So our Q2 is equal to a charge small letter q, hence you have this equation. So Q over 4 pi epsilon naught R is option B. So B is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. This is Jamb 2011 Physics Past Question 37. Three similar cells, each of EMF 2 volts and internal resistance 2 ohms, are connected in parallel. The total EMF and total internal resistance are respectively A 2 volts and 6.0 ohms, B 6 volts and 0.7 ohms, C 6 volts and 6.0 ohms, D 2 volts and 0.7 ohms. Now we're asked to find the total EMF and total internal resistance of three similar cells which are connected in parallel. Okay, now the first thing to note about the EMF, so let's get the EMF first. Now the first thing to note about this is that total EMF for parallel circuits, total EMF in parallel connection is equal to the EMF of each cell. So since the three similar cells each have EMF of 2 volts, that 2 volts is the total EMF as long as the connection is parallel. So we have gotten our total EMF, which is 2 volts. Now of course the total internal resistance 1 over R will be giving us 1 over R1 plus 1 over R2 plus 1 over R3. That is 1 over R is equal to 1 over 2. Okay, the individual resistances are 2 ohms and for 3 cells. So 1 over 2 plus 1 over 2 plus 1 over 2, which is equal to 3 over 2. Therefore, R is equal to 2 over 3, and that is equal to 0.67 or approximately 0.7 ohms. So our EMF, total EMF is 2 volts and our total internal resistance is 0.7 ohms, and that's what you have as option D. So D is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 38. In homes, electrical appliances and lamps are connected in parallel because A. Less current will be used, B. Less voltage will be used, C. Parallel connection does not heat up the wires, D. Series connection uses high voltage. So I asked for the reason why in homes, electrical appliances and lamps are usually connected in a parallel connection system. Now the major reason for this is because if they are connected in series, so series connection use high voltage. This is actually the reason why the appliances are connected in parallel. Now this is because when they are connected in series, the effective voltage in a series connection is the sum of the voltage of the individual appliances. So in a series connection, the effective voltage or the total voltage is the sum of the individual voltages of the appliances. But for a parallel connection, the effective voltage is not the sum of all the appliances. So definitely for a series connection, the voltage will be higher than for when you have a parallel connection. So series connection uses high voltage, option D, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 40. Which of the following will be applied when a metal Y is used to electroplate another metal X in electrolysis? A. Y is the cathode and X is the anode. B. Y is the anode and very high current is used. C. X is the anode and very high current is used. D. X is the anode and Y is the cathode. Now, there is a particular phenomenon that occurs during electrolysis, and during electrolysis, metals and hydrogen are deposited as the cathode. Meanwhile, non-metals and oxygen are deposited at the anode. Okay, so this then means that for this scenario that is given to us, since Y is used to electroplate another metal X, it means that Y is the anode. Metal Y is the anode, hence used, or since it's a metal, of course it will be deposited at the cathode. So Y will be used as the anode, and then it will be deposited on X, which will be used as the cathode, because metals are deposited at the cathode. So Y is the cathode, Y is the anode rather, and X is the cathode. So option B says Y is the anode and very high current is used, which is correct. So B, Y is the anode and very high current is used, is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Jamb 2011 Physics Past Question 41. A radioactive isotope has a decay constant of 10 raised to the power minus 5 per second. Calculate its half-life. A. 6.93 times 10 raised to the power 4 seconds. B. 6.93 times 10 raised to the power minus 6 seconds. C. 6.93 times 10 raised to the power minus 5 seconds. D. 6.93 times 10 raised to the power 5 seconds. So we are given the decay constant of a radioactive isotope, and we're asked to calculate its half-life. So there's a relationship between decay constant and half-life. Now half-life, represented as T, is equal to 0.693 over the decay constant. So T is the half-life and lambda is the decay constant. So that means T is equal to 0.693 over 10 to the power of minus 5, and this is equal to 6.93 times 10 raised to the power of 4 seconds. This is the answer to the question, and that is option A. So the half-life of the radioactive isotope is 6.93 times 10 raised to the power of 4 seconds. Thank you, and please subscribe to this channel for more videos and for more past questions and answers.